Hello everyone, welcome to my presentation. My name is Shunanda Guha. I'm a master student in computer science department at Missouri State University, currently pursuing my degree under the supervision of Dr. Rajiv Iqbal. The title of my presentation is Human Emotion Detection in Smart Homes. The objective of our research is to predict the emotional state of the smart home user from his or her voice commands to suggest appropriate actions. The core motivation of our research work is to enhance the inhabitants' quality of experience and to reduce the gap in human computer interaction. Here we highlight some of the background studies on emotion detection from audio conversation, where several machine learning classifiers were applied for different datasets. The key component of emotion detection from audio conversation are audio feature extraction and choosing appropriate machine learning classifier. In this study, we have introduced two novel audio features named word gap length and word chunk length, along with widely used MFCC feature, and performed a comparative study on several machine learning classifiers to detect the most appropriate algorithm for our problem definition. To best of our knowledge, there is no existing smart home voice command dataset. Thus, besides Rafters dataset, we have come up with a novel in-house dataset on smart home voice commands, which consists of 440 short commands used in smart home applications as shown in the table of sample voice commands. As shown in the workflow diagram, we train our system model based on 80% of the dataset as training data and then determine the accuracy of the model based on its happy, normal, and angry emotion prediction from the rest 20% tested. The figure shows core concept of word gap length and word chunk length extraction. As there is practically no silence period in a natural audio signal, we set a maximum threshold below which all audio components are considered as silent. The interval of each silence period is measured and the word gap length feature for a specific audio input is then measured from the mean duration of the silence period. We also discarded the first and last silence periods to ensure consistent feature extraction as these two segments vary depending on the user. Moreover, the time to utter the same word in different states of mind will also vary, which can be evaluated by measuring the time duration to utter each word in an audio. Beginning of a new word is detected when the signal strength is above the threshold and the end is marked when the signal falls below it. Thus, the time difference between these timestamps of silences will correspond to the time interval of each word. To extract the word chunk length feature, we then measure the mean time interval of the words of an input audio file. To evaluate the performance of different classifiers, at first we chose Rafters dataset and applied several classifiers. Here the table shows that Teapot outperforms the other classifiers when we extract MFCC feature. To determine the best audio features that can highlight the correct emotions, we considered the combination of MFCC word gap length and word chunk length utilizing Teapot. The combined features increase the accuracy of detecting emotions than the accuracy obtained from MFCC alone. We conducted similar evaluation for smart home dataset and the table shows that considering silence length in word gap length and word length in word chunk length together with the spectral shape of MFCC feature can detect human emotion in a better way. From this confusion matrix, we can see that our model can detect 97% normal, 96% angry, 93% happy emotions accurately. This paves a highly promising research direction to detect the user emotion from voice commands in smart home context. The accuracy increment discussed in the tables indicates a larger dataset containing smart home voice commands can further improve emotion detection according to our proposed app. Hence, we are actively working on increasing our smart home dataset contents. We also plan on improving the system accuracy by incorporating advanced machine learning classifiers such as by LSTM, deep neural network, deep belief network, etc. Thank you.